All right, so in the effort to help you try to tackle some of these problems, this is coming from chapter 4. This is basically talking about probabilities and how we calculate things. So if you got a problem that was asking you how to identify or build a table based on false positives or false negatives or negative test results or positive test results. So suppose if you look at my slides, this goes along with this example where we have a drug test and then we have whether the user actually used drugs or did not use. So when we construct this, we'll have subject. Of course, after I get everything up and running, the pen's going to die. Subject uses drugs. So it's going to be a table like this, and this is going to be subject does not. Now, right here we might have positive test result, negative test result. Right? So in this case, there were 44 true positives, 6 false negatives, and 860 in this case that were true negatives. And here we'll have 90 false positives. Now, one thing I do when I build tables like this is I'll make an extra set of lines. Down here, this should be your grand total of what all these sum together. So 6 and 44 gives me 50. 860 and 90 gives me 950. Those two together give me 1,000. So if I add these two together, it should give me 1,000. So we get 866, and 90 and 44 gives me 134. Add those together, it gives us 1,000. Good. Checks off. So that's how we construct one of those tables. Now, if I propose to you that the probability the subject had a positive test result, that's going to be equal to all the positive tests, which is 134 divided by the total of 1,000. Now, if I said the probability the subject tested positive and used drugs, you can see this has "and" in it, which means that they both must happen together. So in this case, intuitively, you can see subject test result is positive here, and uses drugs is this. So it's actually going to be this box right here. So it'll be 44 out of 1,000. All right. Now, if we do the probability, I want to make sure we're still on there. Subject tested positive or used drugs. That's going to be equal to, so we have or, which means we'll have the addition rule, which means we add probabilities together. So positive is this column right here, and used is this column right here. So you might intuitively see that it's 90, 44, and 6 divided by 1,000, and that'll be your answer, which is 140. But let's show you. So you have 90 plus 44 plus 6, all divided by 1,000. So that gives you 140 over 1,000. In other words, about a 14% chance. Now, let's say you wanted to show how to do this. Positive test result, if we do the probability of A or B, that's equal to the probability of A plus the probability of B minus the probability of A and B. And you'll see why here in a second. So probability of A is the subject tested positive. So positive is this, which is 134. So 134 out of 1,000 plus the probability of B, which is uses drugs, which is 50 out of 1,000. Now minus the duplication of this 44. Otherwise, if you don't subtract this off, you're overcounting 44, right? Because 134 is 90 and 44 together, and 50 is 44 and 6 again. So you double counted the 44, and that's why we subtract it off. And this will give you 140 out of 1,000. So that's how to do a couple of those. Now, let's move it to make it a little more complex, and hopefully not run out of room. If we do the probability of positive given the used drugs. So this is like the probability of B given A. All right? So that's equal to the probability of A and B divided by the probability of A. So in this case, the probability of, so first, let's do this. Probability of positive given the used drugs. So given the used drugs, so they're in this row right here, you're going to have a total of 50 and positive. So that would be 44 out of 50. Let's see if we can get that answer now from doing this formula. So the probability of A and B, right, we got that up here, was 44 over 1,000. Now the probability of A, which is used drugs, is 50, oops, not 500, 50 over 1,000. Now, you guys remember when we have two fractions, you multiply, flip, and multiply by the reciprocal. So this is the same thing as 1,000 over 50. And those will cancel out, and we're left with 44 over 50. And that is your probability of getting a positive test result given the used drugs, which makes sense. You would hope that the test would show that if you use drugs, you should probably have a positive test result. In this case, it's about an 88% accuracy. All right, great. That is some of the questions you might encounter in the future, but this is basically pertaining to Chapter 4. So